So let's go ahead and get started with the domain question here. We have a domain of a rational function, excluded values. The function g is defined as below. X minus 4 divided by x squared minus 25. So when we're concerned with domain in any kind of function, there's really two major things we need to look for. First off is what we've got going on here, where we have a fraction and a variable in the denominator of the fraction. Because having a variable in the denominator of the fraction, if I can talk tonight, means that there's usually some value that you can punch in for that variable that will require, or that will turn the variable into a 0, and you can never divide by 0. Because I can divide 0 into 15 groups, because then I've got 15 groups in 0, and that's okay. But if I tried to divide 15 into 0 groups, I can't do that. I've got that 15, it's got to go into a group somewhere. So you can never divide by 0. And that's what we're going to be looking at here. The other thing that we don't have going on in this one is if we're taking a square root. Trying to take a square root of a negative number can never happen. So you would look for something that would make it, whatever's underneath the square root, go to negative. But again, we're not dealing with that here tonight. We're just dealing with the function we have here. And since we're primarily concerned with the denominator not being equal to 0, we're going to say, if this wants to work, we're going to set the denominator equal to 0, because that's what we don't want. And we're doing math, so we do the opposite. Since we have x squared minus 25 is equal to 0, we're going to move that 25 to the other side. Get to x squared equals 25. And now if I take the square root of both sides, I'll get that x can equal either positive or negative 5, because positive 5 squared is 25 and negative 5 squared is 25. And then once we do that, we find everything that can't be in our denominator. Those are our excluded values. And because of the way they worded this, they just said find all values of x that are not in the domain of g. If there's more than one value, separate them with commas. So we would very likely just enter this as x equals 5, comma, x equals negative 5. Another way that they didn't ask us to do here, I'm going to do it just for the sake of showing, would be interval notation, where we know that x can be everything except for 5 and negative 5. So I would say that it would start at negative infinity, go up to negative 5, be unioned with negative 5 to 5, and also unioned with 5 to infinity. Does anyone have any questions about all that? Just put a Y or an N into the chat box if you could, please. All right, let's go ahead and pull up the practice problem. Feel free to ask any questions in the chat. Otherwise, I'll be sitting silently. I'll give you about 20, 30 seconds here to work on this. All right, does anyone need any more time? Again, we've got a function where we've got a variable inside the denominator, so we're going to set that denominator equal to 0. So we have x squared minus 25 equals 0. Add 25 to both sides. Get x squared equals 25. Square root of both sides, we'll find that x is equal to positive and negative 5 again. Alrighty, I'm going to go ahead and presume no questions since that's the exact same thing and move on to number 2. Dividing rational expressions using multivariate monomials. Basically just means, hey, we've got a bunch of stuff going on in here. Can we get rid of any of it and cancel some stuff down if possible? And they threw in some extra fun because, yay, fractions, and we're dividing by a fraction. But fortunately, that is super easy to deal with. We're going to use the keep it, change it, flip it technique, where we're going to keep the first fraction, change the sign, and flip the second fraction. So we wind up with 4bc divided by 5c cubed. We're going to change that divide to a multiply. And then we're going to flip the second fraction and get 25c over 2b. Now looking at this, there's some stuff that cancels out between the numerator and the denominators, and it doesn't matter if it's right over each other or across from each other, diagonally. For example, we've got a 4 in the top of this left side fraction and a 2 in the denominator of the right side fraction. And since 2 divides into 4, we're going to simplify that down. And 4 divides by 2 leaves us with 2. 2 divides by 2 and leaves us with 1, which we're just going to go ahead and leave out of it because we've got other stuff going on in the denominator, and 1 times anything is whatever you multiply it by. Over here in this denominator on the left side, we've got a 5, and in the numerator, we've got a 25. Since 5 goes into 25, we're going to go ahead and divide that out. Cancel that, the 25 down to a 5, and this 5 goes down to a 1. And of course, we're just going to leave that as it is. In the numerator on the left side, I've got a b, and in the denominator, I've got a b, so we can cancel both of those out, because b divided by b and leaves 1, and b divided by b and leaves 1. Now up top here we've got 2 c's, one on the left and one on the right. So if we multiply that, we would get c times c is c squared, and we have a c cubed in the denominator. Since we have these 2 c's up top, and c cubed is really the same thing as just having 3 c's in the bottom, we're going to cancel out these 2 c's with 2 of the 3 c's here, and just be left with the 1 c left in the denominator. And now this actually cleans up pretty nice. We've got this 2 left up top, and this 5 left up top. 2 times 5 is 10. And in the denominator, we've just got that c left. So everything boiled down just to 10 over c. Everyone comfortable with that? All right, I'm going to go ahead and throw up the practice problem. Again, I'll just give you a little bit of time here. Feel free to ask any questions in chat. All right, does anyone have any questions? Or are we ready for me to go through this? All righty, let's go ahead and plow through this then. Again, we're dividing with fractions, so we're going to use keep it, change it, flip it. Keep the first one, gives us 3a to the 4th y squared divided by 2y. We're going to change that divide to a multiply and flip the second fraction to get 8y divided by 15a. Again, we're going to look to see whatever we can cancel out between the numerator and denominators. Here we've got a 3 in the numerator and a 15 in the denominator. Since 3 goes into 15, 3 divides by 3 and leaves 1. 15 divides by 3 and leaves 5. And the 2 can go into the 8 and leave 4. And then 2 would just cancel down to 1. The a to the 4th, so there's 4 a's up top. And in the denominator, we've just got this one little lonely a down here, so we're going to get rid of him and cancel out that 4 and make that a 3 instead. So I've got y squared and another y up top makes y cubed, so 3 y's up top, and then just this one y down here. They cancel that out. I'm actually just going to go ahead and cancel it out with that one to leave the y squared alone over there. And this leaves us with 4 up top, a cubed, and a y squared all over 5. Any questions? All right, let's go ahead and move on to the next one. Hey, if I can get it to click. There we go. Okay, we're simplifying a ratio of polynomials. Problem type 2. Simplify. U squared minus 7u plus 6 divided by 3 minus 3u squared. Anytime you're simplifying big stuff like this, it's easiest to break it down into the smallest chunks that you possibly can, which means factoring. And since up top, we've got our lovely 1 coefficient on our u squared term, we can factor this out pretty simply by figuring out factors of 6 that add up to make 7. 6 and 1 comes to mind pretty quickly, and since this is a negative 7, it's going to have to be negative 6 and negative 1, because negative 6 times negative 1 makes a positive 6, and negative 6 plus negative 1 makes a negative 7. So we can factor our numerator down to u minus 1 times u minus 6 divided by, in the bottom here, we've got kind of a two-step going on. First thing I'm going to do is I'm going to factor out that 3. And that'll leave me at 1 minus u squared on the inside, because I took the 3 out of that 3 and got left with 1, took the 3 from that 3u squared and got left with just the u squared. Now what's going on here is I've got a difference of 2 squares, because 1 is the same thing as 1 squared minus u squared. That's going to leave me with the form of 3 times 1 minus u times 1 plus u. Because that's how we factor down the difference of 2 squares. So now we can take a look and see if there's anything that matches. Unfortunately, there isn't, but this kind of looks like it should match. We've got u minus 1 and 1 minus u. And the way we're going to deal with that is, because they're in the wrong order, if we take out a negative from there, it's going to change things. There, okay. So up top, I'm going to leave that u minus 1 times u minus 6. And in the bottom, I'm going to pull a negative out of this and get to negative 3. Sorry, I can do better than that. 1 second. There we go. And 1 divided by negative 1 is going to be negative 1. Negative u divided by negative 1 is going to leave me at plus u. And I could actually just go ahead and rewrite that as u minus 1 because those are the same thing. And then over here I've got 1 plus u or u plus 1. Either way, it's the same thing. Now remember, this and this are the same thing, so I'm going to cross them out at the same time with that. U minus 1's cancel it out. That leaves us with u minus 6 divided by negative 3 times u plus 1. Any questions? All right, let's go ahead and pull up a practice problem for you guys then. Again, just let me know if you need any help. I'll be back in a few seconds. Okay, would anybody like some more time to work on this? All right, let's go ahead and plow through it then. So again, we're simplifying two large polynomials here. First thing that is up top, we've got a lot in common here. There's a negative 5 in each term, really, because we've got negative 5w squared, negative 50 divisible by negative 5, and negative 125 also divisible by negative 5. So the first thing I'm going to do is go ahead and pull that out of there. So I can get left with w squared plus 10w plus 25 divided by w squared. We're actually going to go ahead and factor that out real quick. So factors of 15 that add up to 8 would be 5 and 3. Since 5 and 3 multiplies to make 15 and adds to make 8. So we can call that w plus 3 and w plus 5. Continuing to factor the numerator, we're going to leave that negative 5 out front again. So two things that multiply to make 25 and add to make 10. 5 and 5 comes to mind. You like those 5s up top, don't they? So we have w plus 5 times w plus 5. Again, divided by what we already factored from the numerator or denominator. For w plus 3 times w plus 5. So now see I've got a w plus 5 up top and in the denominator. I'm going to go ahead and cancel one of the ones from the numerator. There's still this one remaining, so I can only cancel the one of them out. That leaves me at negative 5 times w plus 5 divided by w plus 3. Everyone else get the same thing? Alrighty, let's move on to the next question. My computer will cooperate. Okay, adding rational expressions with denominators ax and bx. Subtract 5d minus 3 divided by 3d minus 4d plus 1 divided by 5d. So this leads us into adding and subtracting fractions, wherein the rules are always the same. In order to add or subtract fractions, you have to have the same denominator. So in here, our denominators are 3d and 5d. They both have that d in common, so we're not going to have to change that. But the 5 and 3 aren't in common, so the least common denominator that we can make with a 5 and a 3, easiest way that I like to do it is to just multiply the two. Especially where we have two prime numbers, 3 times 5 is going to be 15. So we need to be able to make a denominator with 15d. And in order to turn this 3d into our 15d, we're going to have to multiply it times 5, which means I have to multiply this entire side times 5. And in order to turn this 5d, or I'm sorry, I need to multiply it by 5 over 5. Didn't really qualify that very well. In order to turn this 5d into a 15d, I'm going to have to multiply it by 3. So I'm going to multiply that one by 3 over 3. When I do this first one, I'll get 5 times 3d is 15d. 5 times 5d is 25d. 5 times negative 3 is negative 15. Minus 3 times 5d is, of course, our 15d on the bottom. 3 times 4d is 12d. 3 times a positive 1 is going to be a positive 3. And now, since I have the same denominator in each fraction, I can just rewrite all that as one fraction, except that when I do this, something that's very important is that we don't lose track of this negative, because this negative applies to the entire numerator. So we want to make sure that we distribute that through. The way that I like to do it to make sure that I don't lose track of it is just put that second denominator entirely in parentheses with that negative in front, because now that tells me that this negative needs to get distributed. So I'll wind up with 25d minus 15. Negative times 12d is going to be minus 12d. Negative times a positive 3 is going to be negative 3. All divided by 15d. So let's go ahead and combine our like terms up top. We have a 25d minus 12d will leave us at 13d. Negative 15 minus 3 will be negative 18. And then our denominator, 15d. Any questions? Let's go ahead and pull up the next practice for you guys. Again, just let me know if you have any questions. All right, would you guys like some more time? Whoop. So let's get through this one then. So we're going to go ahead and subtract these two fractions. Again, I've got uncommon denominators. They both have a y in common, but I'm going to have to multiply to get 7 times 3 is 21. So the first time I need to multiply the 7 times 3, like I said, to get this to 21, and on this side I need to multiply by 7 over 7. So top 3 times 5y will give us 15y. 3 times a positive 1 gets us positive 3, divided by our 21y, minus 7 times 3y is going to be 21y. 7 times a negative 2 will be negative 14, divided by 21y. Okay. Again, I want to keep track of that negative, so I'll rewrite it with 15y plus 3 minus, and then in parentheses, 21y minus 14. All divided by our 21y now. So lets me distribute that negative through, so I get 15y plus 3 minus 21y. Y, and negative times a negative is going to make positive, so positive 14 divided by 21y. And if we clean up our like terms, 15y minus 21y is negative 6y, plus 3 plus 14 is positive 17, all over 21y. Any questions about that? Where did my mouse go? Here we go. All right, let's move on to the next one here. Adding rational expressions with linear denominators without common factors. All right, so this one's going to be a little bit trickier than our last one, but really it's kind of the exact same thing. Where we have two different denominators, they're not being multiplied this time. Last time we just had like 3y and 7y, so we didn't have to deal with the positive and negative in between them. And whenever you're adding and subtracting terms, it kind of changes things up a little bit. So here our common denominator, though, is going to be the same technique. I've got x minus 6 and x minus 2. I'm just going to multiply them to find the common denominator that would look like this. X minus 6 times x minus 2. So now in order to get this side to look like that, I've got to multiply times x minus 2 and x minus 2. And over here I have to multiply times x minus 6 and x minus 6. So up top then, I'm going to wind up with an x minus 2 times x plus 9 plus, or you know what, I'm going to keep that out there because I like to keep that same technique. Even when I'm using a positive and I know it's going to turn out the same, if you follow the same steps every time, even when you don't need to, then when you do need to, you don't forget to do it. So up top we've got x plus 4 times x minus 6 over x minus 6 and x minus 2. So top still I've got that x minus 2 times x plus 9. Fortunately, they're already in parentheses, so I can just tack that plus into there. X plus 4 times x minus 6. Ooh, big smiley face there, huh? Over x minus 6 times x minus 2. Now we got a few more steps to go because we're going to need to FOIL these out a little bit. So in the first terms, we've got x times x is x squared. I know that when I do this, because both of my leading coefficients are 1, I'm just going to have minus 2 and plus 9x. So minus 2 plus 9 is going to be plus 7x. Again, that would be because the negative 2 times x and the positive 9 times x, and those would combine to make a positive 7x. And then I can multiply these two terms. Negative 2 times positive 9 is going to be negative 18. Plus, again, here I've got 1 for my coefficients on x, so I'll wind up with x squared. Plus 4 minus 6 will be a negative 2x. And plus 4 times negative 6 will make a negative 24. All still over that x minus 6 times x minus 2. So if we go ahead and FOIL that out, we get x squared. Actually, you know what? I'm not going to FOIL that out just yet, just because they say simplify your answer as much as possible. And even though I really don't expect it to happen, there's a very slight possibility that we might be able to factor out our resultant of these two to find something that boils down nicely. So when I do that, x squared plus x squared makes 2x squared. And I like to cross stuff out as I go just to make sure I haven't lost track of anything. Plus 7x minus 2x is going to make positive 5x. And again, I can cancel those out now. Negative 18 minus 24 is going to be negative 42. All over x minus 6 times x minus 2. If I did the AC method on this, we'd get 2 times negative 42 is negative 84. Then we need factors of negative 84 that add up to make 5. So it'd have to be two things really close together. Shoot, what goes into 84 that'd be really close together? How about something like, let's see, we do 4 and 21, but that doesn't really work. 12 and 7 works, though. So I could factor that to 2x squared, let's see, plus 12x minus 7x minus 42. Break that up, I would get a 2x on the outside times x plus 6. Over here I can factor out a negative 7, x minus 6. Or, no, I apologize, x plus 6, because I pulled out a negative 7. So that leaves me with the factors of 2x minus 7 times x plus 6, which, as we see, there's nothing to cancel out because I have an x plus 6 up top, basically, and an x minus 6 in the denominator. Doesn't do us anything. X minus 2 and 2x minus 7. So this could be our final answer right here. There's nothing left to cancel out. Any questions about that? All right, let's go move on to the practice question then. Let me know if you need any help. All right, would anybody like any more time on this? Okay, so we're going to subtract two fractions this time. Again, we're just going to go ahead and multiply our denominators to find that our least common denominator is going to be 8x times 7x minus 6. To get that, I need to multiply the left side times 8x on the top and bottom. And I need to multiply the right side times 7x minus 6 on the top and bottom. So up top then, I've got 8x times x over our common denominator minus, up top here we've got x plus 2 times 7x minus 6 over our common denominator. For right now, with that minus in between, I'm going to go ahead and distribute up or multiply up top to get 8x times x is 8x squared over the denominator minus, if we distribute this one, x times 7x squared, or I'm sorry, x times 7x is going to give us 7x squared. Since we got that 7, we're going to do 7x times 2 is a positive 14, and then 1x times negative 6 is negative 6. 14 minus 6 is a positive 8x. Then positive 2 times negative 6 is negative 12, divided by our denominator. And again, we have that negative in here, so I'm going to distribute that all the way through. And to do that, do 8x squared minus parentheses and then everything that's on the right side, the 7x squared plus 8x minus 12 divided by 8x times 7x minus 6. That negative goes all the way through to give us 8x squared minus 7x squared minus 8x. Negative times a negative makes a positive 12 over 8x times 7x minus 6 again. Now when I clean this up, 8x squared minus 7x squared will leave me at just x squared minus 8x plus 12 over 8x times 7x minus 6. And again, if I factor this numerator, this time it's nice and easy. It's a 1 coefficient. So two things that multiply to make 12 would be 6 and 2 to add up to make 8. So it has to be a negative 6 and a negative 2 to make a negative 8. And x minus 6 and x minus 2, nothing would cancel out the denominator. So we can leave it just as it is, or we could even distribute that denominator through if we wanted to, or if your teacher wants you to. Always good to make sure you know what kind of form your teacher wants on the test. So 8x times 7x will leave us at 56x squared, and 8x times negative 6 minus 48x. Any questions? All right, let's go ahead and move on. Simplify. 3 divided by 4 minus 5 over 2 divided by 1 divided by 4 minus 2/5. Well, whenever you're dividing by a fraction, you can do the keep it, change it, flip it, but in order to do that, you can only have one fraction in your denominator. So in order to deal with that, we're going to go ahead and rewrite the numerator and the denominator as just one fraction. Up top, if we find our common denominator, it would be 2 times 4 is 8. So I'm going to have to multiply this 4 times a 2, means the top has to be multiplied by 2, and this 2 times a 4, means the top's by 4. In the denominator, our common denominator would be 4 times 5 for 20. This 4 needs to get multiplied by 5. This 1 by 5. This 5 by 4. So this 2 by 4. We go ahead and multiply everything. We get 2 times 3 is 6, divided by 8, minus 5 times 4 is 20, divided by 8, divided by 5 times 1 is 5 over 20, minus 2 times 4 for 8 over 20. Now, since they both have common denominators, we can go ahead and clean those up into single fractions up top. 6 minus 20 is a negative 14, divided by 8, divided by 5 minus 8 is a negative 3, divided by 20. And now, since we have one fraction in the denominator, we can do the keep it, change it, flip it. So I'm going to keep it, change it, flip it. We're going to keep the negative 14 over 8, change the division, which is really what this fraction means, is division, so multiplication, and flip the flip the denominator to be 20 over negative 3. If we take a look, 3 is a prime, so it doesn't go into 20 or 14, so that one's going to have to stay. 8, however, can divide by 2, and 14 and 20 both divide by 2. I'm going to go ahead and try to pull out as much of this 20 as I can to reduce that down to a smaller number. So the thing in common between 8 and 20 would be 4. So 4 goes into 8 and leaves me with 2, and 4 goes into 20 and leaves me with 5. And actually, while this 3 doesn't go into anything, this negative can cancel out with this negative. So now I'm left with 14 times 5 is 70, divided by 2 times 3 is 6. And I wasn't paying enough attention because 2 can go into 14 as well. The way I can tell is because when I get down to the end here, I've got 70, which is even, and 6 is even. Obviously, something else can cancel out at that point, which would be the 2. 70 divides by 2 and leaves me at 35. 6 divides by 2 and leaves me at 3. Any questions? Where's my mouse go? There it is. Let's move on to the practice problem here. If my computer will cooperate. Oh, come on. There we go. Let me know if you have any questions. All right, are we ready to continue? All right, so again, we need to simplify with two fractions on top and two fractions on the bottom. So if I look for my common denominator, again, I'm just going to go ahead and multiply 5 times 3. So I need to multiply times 3's on this side and 5's on this side. And in the bottom, 4 times 2, so 2's over here and 4's over here. That'll give me 3 times 6 for 18 over 15 minus 5 times 5 is going to be 25 over 15 divided by 2 over 8 minus 12 over 8. Go ahead and simplify that down. 18 minus 25 is 7 over 15 divided by 2 minus 12 is negative 10. I'm sorry, that should be negative 7. Yep. And so 2 minus 12 is negative 10 over 8. We're going to do keep it, change it, and flip it. So we have negative 7 over 15 times 8 over negative 10. The two negatives can cancel out. 8 and 10, they both have a 2 in common, so I'll just go ahead and factor that down to be 4 and 5. That'll leave me at 7 times 4 for 28, and 15 times 5 is 75. Is that what everyone else had? All right, good deal. So looks like we've still got one more here. Simplifying a higher radical expression, multivariate. Write the following expression in simplified radical form, which really means, hey, if there's some stuff that we can get out of here, let's get it out. Since we're looking for a cube root, we need to have stuff that has that's in there at least 3 times. And we're going to start off with the 27. To get that down to its smallest base would be 3, because 3 times 3 is 9, times 3 is 27. So that 27 can be rewritten. I'm going to keep my cube root for now. 27 can be rewritten as 3 cubed. And we have that t to the 5th and w to the 11th. So now what we do is we're going to do 3 divided by 3. That happens to divide cleanly, so we can pull out one of these 3's. Going to come out front. And since it's divided cleanly, there's no remainder left, so there's nothing left inside here. 5 divided by 3, or sorry, let's cross that out. 5 divided by 3 will go in one time, pull out that t. That's going to leave me a remainder of 2. This 5 divided by 3 is 3 plus 2. So it's going to leave me at t squared. That one's dealt with. Here we've got w to the 11th. 11 divided by 3, well, I can pull 3 out 3 times. So I get w to the 3rd. And when I do that, I'm again going to have a remainder of 2, because 3 times 3 is 9. 11 minus 9 is 2. So this is what's left on the inside now. So I've got this cube root of t squared. I can do a little bit better. Ever so a little bit better. And w squared for my final answer. Any questions? All right, I'll give you guys a few seconds to work on this one, and I'll check right back in on you. And we're going to go through some variant questions really quick. All right, are we set for the explanation of this one? All right, let's work through it then. So again, the first thing I want to do is I'm going to rewrite this 16 with its smallest base, which I happen to know is 2. If you're not really sure, most of the time with even numbers you can pull out a 2, but the best bet is to make a factor tree if you're absolutely not sure what you can do, and then see which factors come out the most. In this case, this would be 2 times 2 is 4, times 2 is 8, times 2 is 16, so that was 4 of them. So we have 2 to the 4th, and this is a 4th root. We have x to the 13th, and g to the 5th. So again, 4 divides by 4 cleanly, and this leaves me with a 2 outside. That's dealt with. 13 divides by 4 3 times with the remainder of 1. Since 4 times 3 is 12, and 13, I say 1, and I write 2. How about that? 13 minus 12 is 1. So, like I said, it pulls out 3 times. So I'm going to pull x to the 3rd out. That one's dealt with. 5 divides by 4 1 time with the remainder of 1. So that leaves me 1g outside. And now I've got this 4th root of xg. Any questions? All right, so for this next part here, I'm going to show you 2 of them and have you work on a practice one that is going to combine the 2 that we worked through. Excuse me for one moment, please. Excuse me. A little froggy in my throat there. So on a given planet, the weight of an object varies directly. And I'm going to pause right there. It tells me the weight of an object varies directly. So when it does that, that tells me what's going to be on the left side of my equation. Since it's referring to weight, I'm going to call it W to refer to weight. And say that equals something. And no matter what kind you're working on, there's going to be a K involved. Now, whether you're multiplying times the K or dividing the K is what comes into play. So let's read through the rest of the question and see which one this is. Since it says that it's varying directly, that means that we're going to multiply times K. And it says we vary directly with the mass of the object. So I'm going to call that M. Suppose that an object whose mass is 7 kilograms weighs 70 newtons. So what that tells us then is that when we have a mass of 7 times this K, the result is that we get this weight of 70 newtons. And I'm not going to go get into the unit factors here. In order to solve for K, we can divide by 7 on this side and 7 on this side and find out that K is equal to 10. Okay. Now it says calculate the mass of another object that weighs 30 newtons. Well, if we've got the weight of 30 newtons, and we know that that equals this K of 10 times some mass, then the mass is simply found by dividing both sides by 10. Which leads us to the M is going to be 3. And in this case, we're going to go ahead and tack on that kilograms, just because they might be curious about our units. Any questions? Okay. So this one says that Boyle's law says the volume of a gas varies inversely. Well, I'm going to pause right there. Volume of a gas varies means that on the left side here, I'm going to have some variable. I'm going to call that V for volume equals something with K. It says varies inversely. Inversely means I'm going to be dividing instead of multiplying. It says it varies inversely with the pressure, so I'm going to call that P for pressure. When the volume of a certain gas is 5 liters, so the volume is 5, equals K divided by pressure. The pressure is 568. Wow. So if we go ahead and work through that, we can multiply both sides by 568. And that'll cancel out over there. I really wish I had a calculator handy. So 5 times 8 is 40, carry the 4. 5 times 6 is 30. So 30 plus 4 is 34, carry the 3. 5 times 5 is 25, plus 3 will be 28. So K equals 2840. What is the volume when the pressure is 710 kilopascals? So they're saying, what is our volume, which we don't know, when we have our K is now 2840 divided by 710. Fortunately, I can tell that one's going to be V is equal to 4. Everyone following along so far? All right, I'm going to give you guys about 30 seconds here to work on this one. Like I said, this one combines both of the last things, so be very careful. When you see varies directly, it multiplies times K. When it varies inversely, it's going to divide K. Go ahead and work through this. I'll be back in just a little bit. All right, is everyone ready for the explanation on this one? All right, good deal. Suppose that the amount of time it takes to build a highway varies directly. Since we're talking about time here, you can really say time or the highway. I'm just going to call it time for T. Varies, so something with K, varies directly with the length of the highway. Well, length, I'm going to call that L. And inversely with the number of workers. I'm going to call that W for the workers. Suppose it takes 150 workers, so 150 workers is going to replace my W. I'm not too sure exactly what all is going to get filled in here, so let's go one at a time. But we know that K is still going to stay there. It takes 150 workers, 14 weeks, so our time is 14 weeks, to build 12 miles of highway. Well, 12 is going to be our length. So if we go ahead and solve this one for K, up top I can take a 3 out of both and get left with 4 and 50. Then I can see that I can take a 2 out of both of these and get left with 2 and 25. So now I have to multiply both sides times 25, because that cancels out over here. And then divide both sides by 2. Sorry, that looks really ugly. Let me clean that up just a little bit here. So I had gotten it down to, we had 14 equals K times 2 divided by 25. So now if I multiply by 25, these cancel out. You can see what's going on a lot better. Then if I divide by 2, these cancel out. So that's what I've got going on over here. 2 goes into 14, leaves me at 7. 7 times 25 is 175, so K equals 175. So how many miles of highway? So we're looking for the length. So we're going to have our K of 175, and we're looking for length, so that's going to have to stay there. How many miles of highway could 125 workers build? So 175 divided by 125 in 21 weeks. Again, I can see that 25 goes into both 125 and 175. That'll cut down to 7. This will cut down to 5. Makes life a lot easier. Multiply both sides by 5. Those cancel out. Divide both sides by 7. So that those cancel out. We'll get down to L equals 21 times 5 divided by 7. Well, 21 divided by 7 leaves me at 3. 7 would go away. 5 times 3. The length of time would be 15 weeks. Any questions? All right, well, it's been a pleasure helping you guys. We'll look forward to seeing you again Wednesday evening. Sorry, I ran a little bit over here, but I hope it was very helpful for you guys. You have a great night.